Now let's talk about the properties for the logarithmic functions. So the first one, which is called the change of base formula. So that means we want to change the base of the logarithmic function. Okay. So here we assume that the base is always greater than 0 and it's not equal to 1. So if we have a log with base a of x, we want to change the base a to b. What we should do? It's actually equal to log base b of x divided by log base b of a. Right. So we know there are some special logarithmic function, which is the base is 10 and the base is e, right? So if we want to change the logarithmic function with base a of x to the base 10, so it would be log 10. Log 10 is just log of x over log of a. Okay, so if we want to change to the base e, it would be ln x and ln a. So here is the one example. If you have log 4 of 25, so if we want to evaluate this one, we notice that our calculator cannot do that, right? The calculator only can do the natural log, ln, and the common log, which is log only, right? So what we should do? We can change the base. If we want to evaluate it, we can change the base. Let's change the base to ln 25 and ln 4. Then you can use your calculator. You will get this 2.3219. Okay, or you can do the same thing. Log 25, which is the log 25 and the log 4. Then you have the button for the log function with the base 10. Then you use a calculator, you will get the same answer. Okay, so this is the change of base formula. So now the second part is some properties, okay? The first one is if you have the log a of u plus log a base a of v, what's that? It's equal to log with base a u times v. And you have log a of u minus log a of v. What's that? It's equal to log a of u over v. Then you have log a of u to the n. So this is it's equal to, you can bring this n down, okay? In front of log, it becomes n times log a of u. Okay, so this is some very important properties. And sometimes we like to use the natural log, so there is a corresponding one where a is equal to e, so it becomes natural log of u plus natural log of v is equal to natural log u times v. Natural log of u minus natural log of v it's equal to natural log u over v. Natural log of u to the n is equal to, we bring down this n and the natural log of u. So here is one thing I should want to mention. This one, ln u to the n, which means ln of u to the n. Okay, so this power n is on u, not on the natural log. It's different from ln u of the total they raised to the power n. Okay, so they're different. So these are some conventions. You should be careful. Okay. So now we want to use these properties to do some calculation, simplification for the logarithms. So the first example, we want to write the following expression in terms of log 2 and log 3, ln 2 and ln 3. For example, we want to write this ln natural log of 6 as in terms of natural log of 2 and natural log of 3. So we notice that 6 is equal to 2 times 3, right? So you can, using this property, right, this part, which is natural log of 2 plus natural log of 3. If you have 2 over 27, so this one can be written as natural log of 2 minus natural log of 27, right? And we know that 27 is equal to 3 cubed. So you can bring down 3. So this is natural log of 2 minus 3 times ln 3. Okay. Another example, we want to simplify this one. Log 5 of square cube root of 5. Can we simplify this one? So the idea is, so we first thing we needed to write this part as the power form. Okay, so it becomes the log of 5 base 5 of 5 to the 1/3, right? Then the next thing is we can bring down this power, right? Like this part. So it becomes 1/3 times log 5 of 5, which is equal to what? Equal to 1/3 times 1, right? This is a 1, because we know if you have log a of a, it's equal to 1. So we have this property in the previous section. So this is equal to 1/3. So now let's calculate ln e to the 6 minus ln e to e squared. Okay, of course you can combine these two terms. You can say, okay, it's equal to ln e to the 6 divided by e squared. So this one is ln e, what? E to the 4th, right? E to the 4th, it would be 4 times ln e, right? ln, which is means what? The log with base e of e, so this is 1. So this is equal to 1, so this is 4. Okay. So here is some common mistake when we do this kind of calculation. If you have the log x, so this means the base is 10, okay, log y. We know by the change of base formula, it's actually equal to the log y and base y of x, right? But be careful, some students always like to write this one as log x over y. No, this is wrong. Okay, this is wrong, so you should be careful. So the next example is we want to condense the logarithmic expression. So that means we want to combine to a single log, okay? Log function, so condense the logarithmic expression. So this one, 2 ln x plus 2 minus ln x, then you can combine. So, but you cannot combine together directly. The first thing you need to bring this number inside this natural log. So we know by this property, if you look at from the left side, right side to the left side, this n is outside. If you want to bring inside the log, it becomes the power of this part, right, of the input. Okay, so it becomes ln x plus 2 squared, then minus x, so it's equal to ln x plus 2 squared over x. Okay. If we want to condense this log, 1/2 log x plus 3 log x minus 1. So what we need to do, bring this one inside the log, so it becomes x to the 1/2, right? Plus the log x minus 1 cube. So if you put together, it would be x 1/2 times x minus 1 cube, right? Or you can write it as the square root of x times x, or you can write it as log square root of x times x minus 1 cube.